Very good evening to one and all gathered here. I welcome you all for class 4 on isometric projection. So before moving to the today's class on isometric projection, I just want to give some comparison between the previous the class topic orthographic projection. How far the isometric and orthographic projection both are differing with respect to the conceptual idea. In orthographic projection, we have to draw multiple view in 2D sketch, say front view, top view, side view. All the views are represented in 2D view, whereas in isometric projection, we can combine all the three different view by using a single projection system called isometric projection. So the other name for isometric projection defined as a pictorial projection. All 3D representation of a physical object can be referred to say as pictorial projection. So a simple way to define isometric, why the name has been called as an isometric. See here, the base edges are equally inclined at an angle 30 degree. So isometric means equal measure of projection. All the sides will be equally inclined, say 30-degree angular inclination, and the vertical edges are facing opposite parallel to each other and perpendicular to the base reference line. So in this way, it has been defined as isometric. Now let us go to the problem. So this is the question. The way they have defined in orthographic view, front view, top view, and left side view. Three different exploded views are illustrated here, and we have to combine all the three views by common the projection, say isometric projection. This is the final answer, but I'm going to explain in 5 different stages how we are getting this 3D block isometric projection for the given 3D object. And these are the scale dimensions that are given here for front view, top view, as well as for the left side view, as shown in the question. Now, as per the given question, we are going to have an individual step-by-step detailed procedural explanation. Starts from the next slide onwards. So in the solution part, first thing in the step 1, construct the isometric axis line x, y, and z. These are the three mutually perpendicular axis plane, axis line, which means at point O, all the three isometric axis lines are commonly intersecting at point O. With the help of the isometric axis line, construct an isometric plane on all various sides so that it looks like a cube in 3D view. Now, in step 2, we have to decide which view should be drawn first, either front view, side view, or top view, left side view or top view. Now, move back to the question of the given problem. So the front view gives the height and the base length of the object in 2D. The top view gives the width and the length of the given object. The side view, which measures the width and the height of the object. So it is mandatory to start drawing the view from the front view's direction. Y means the front view gives the true shape, the real original shape of the object in 2D. So what is the scale dimension here? This line height is 20 mm. From O, we have to draw a vertical line, 20 mm, horizontal line, another 20 mm. Okay, then we have to repeat the same pattern by constructing vertical line, horizontal line, and again another vertical line. All the dimensions are equally, say, 20 by 20, both vertical and horizontal lines. So these scale values are given in the top view. Referring to the top view, okay, through from the projection lines, I can able to read out the dimension scale value. All the lines are said to be 20 mm equal. Now, I need to convey the idea by means of isometric projection. So from point O, draw a vertical line up to 20 mm. Then from here, draw horizontal line 20 mm. Another vertical line, say equal scale 20 mm. Then followed by vertical horizontal line and vertical line. So now this has been defined by means of a 3D projection. Now front view is being uh, given here for the kind reference. So the values are being taken from the 2D projection, orthographic view. Now next, left side view, step number 3. Again moving back to the given problem. So the vertical height of this line is 60 and the width of the line is 50 mm. And the height is vertical height. This distance is 20 mm, the shorter line distance. And the line which moves towards the left side, 30 mm. This horizontal line distance is 30 mm. And this is said to be 40 mm. Each with an equal gap of 20 mm interval spacing. So now we have to sketch the left side view in 3D projection, isometric projection. So draw a line, vertical line for 60 mm, 20 mm, and this is 30 mm, and this is said to be 40 mm. So now left side view is drawn, and front view is also partially constructed, and the remaining one is top view. So step number 4, we have to construct the top view image. So moving back to the question. So here is the top view. So the 2D orthographic view is given here. So from the 2D mapping, so just refer the distance scales. So the top view, the base length is 60, width is 50 mm. So from 50, remaining distance 20, draw a line for 20 mm, 40 mm, 30, then 20 mm. So moving to step number 4, here draw a line for 20 and 40, 30, then again 20 mm. And in the last stage, so we have to draw the visible lines in dark, thick lines. Other remaining features have to be totally discarded after completing the full 3D view of a given object. So these lines are, the adjoining lines have to be connected by constructing parallel perpendicular lines so that the final view of the block can be seen in this form in isometric representation. So these are the different the stages in which we have to solve the isometric projection directly from the 2D view orthographic. So I can show the solution here. So this is the final answer for the given problem. Just I made an attempt to solve in 4 stages, multiple stages, step by step illustration shown as a graph how the isometric view can be drawn in individual segments. Now with this input, the few information, I end the isometric projection, the today's lecture. So thank you all for your gathering. The next class we will meet with another topic in advanced mechanical engineering, say productivity techniques, advanced productivity techniques. So far the basics of engineering graphics we have seen about projection of points, projection of straight line, projection of planes, isometric projection, orthographic projection. So totally 5 fundamental the topics we have covered. So if you have any the queries, so you can contact me at any time by pasting your comments below my channel, the YouTube channel. I'm ready to answer for all your comments. So thank you one and all.